Hello, today we'll be talking about sample preparation for HPLC of benzophenone BZ3 and its metabolite dihydroxybenzophenone DHB from urine samples. Now, the choice of extraction is solid phase extraction, as benzophenone and dihydroxybenzophenone is actually nonpolar, and the urine samples are aqueous in nature. So, extraction of nonpolar from aqueous would be more suitable for solid phase extraction. So initially, what's in the urine sample is urine sediments, which is your proteins and other biological matters, and aqueous urine, which contains the analyte that is dissolved along with other interferences. So in the pre-treatment of the urine samples, we need to centrifuge the urine to remove the solid urine, which is actually like the proteins, which will actually cause damage to the HPLC machine. And this is done by centrifuging at 2100 Gs for 10 minutes. Uh, Next up, when after separating, we can obtain the aqueous part of the urine. So when we get the aqueous part of the urine, we need to actually add the enzymes to break the bonds between conjugated BC3 and DHB, and it will actually break here and free the analyte, which can then go to react with the have interactions with the solid phase later in solid phase extraction, with the stationary phase in later in the solid phase extraction. So we add the enzyme glucuronidase to the aqueous urine sample, and it does this. It helps break apart the analyte and the protein. Then it needs to be incubated for it to work at 37 degrees for 16 hours. Next is dilution. So we add the phosphate buffer and 100 times dilution with 0.9% aqueous sodium chloride. This dilutes the interferences and allows for a decreased effect on the results in HPLC, and we actually allow the range of the concentration range to be within the range that is effective of HPLC. So after those steps, we will be left with an aqueous urine sample with the analyte and other interferences dissolved in the urine. So we need to do solid phase extraction. So in solid phase extraction, there's the pasture pipette, and the solid phase goes in here, and we have a pipe, we have a tap, and there's a waste tank and a vacuum. So how it works is we put in the stationary phase, which is in this case the C8 column, into the pasture pipette. Then we add methanol in, and we open the tap and switch on the vacuum, and the methanol is sucked into the waste tank. So we do this for the 4 steps here with the different solutions. Firstly, methanol, which is to activate the C8 column, allowing it to work for the next few steps. Then we need to add the phosphate buffer. This is to wash away the excess methanol from the first step. Then we load the sample, so the analyte will actually have a higher affinity to the C8 column, and will remain in the C8 column, while other interferences will be washed away with the vacuum. Then we have washing, which is using a phosphate buffer, and while using the phosphate buffer, we wash away any other interferences that were not removed, which is why we only dry fully under the vacuum after we have finished the last washing step. So elution, we add methanol trifluoroacetic acid 1 to 100 into the pasture pipette, and this is the elution solvent. And what this does is it actually allows the it frees the analyte, the DHB and BZ3, and the eluate is then transferred to a glass vial, which is then used for HPLC, the eluate being BZ3 and DHB.